Hello and welcome to the studio here at European Utility Week 2015, and I'm joined now by Peter from UK Power Networks. And just to put it into context why Peter is here, you guys won the Industry Innovation Award yesterday. So firstly, congratulations for that. There was a lot of competition. I think in total there were 150 entrants, so it's no mean feat. But Peter, tell us, what was the project that won? What did you do?
No, the project has been a project that's been funded through our regulating low carbon network fund. So we have this opportunity to do demonstration projects, and our project is called Flexible Urban Networks at Low Voltage. So it's all about trying to share capacity between substations, where you're trying to ensure that looking at the opportunity of deferring capital investment, trying to allow customers to connect to the network where traditionally they may have had to wait for some network reinforcement to take place. So we're providing faster connections and managing the network in such a way that we can manage constraints on the network. So on the we've looked at a number of different technologies on how to provide that simple interconnection between substations. So we've got solutions which join two substations together, solutions that join three substations together.
And you're doing this for network resiliency, or you're doing this for capacity infrastructure deferral, or
it's both. No, they dependent on the various solutions. The very simplest just provides a very simple interconnection where flows take place, but if a fault does occur, the circuit breakers, which are providing that capacity sharing, they will remove the fault. As soon as the fault has been cleared, the circuit breakers test the circuit, and if the fault has gone away, they will reclose and restore our customer supply. So in one hand, it is providing network resilience and improving customer performance, but on the other, it is all about capacity sharing. The other solutions that we've got are really, we're introducing this term, the soft open point, which is where you can join two networks together which traditionally have never been joined together due to a number of reasons. Sometimes it's the level of circulating current just prevents you from joining the two circuits together. So because the devices are back-to-back inverters, so we're converting the AC that we distribute around our networks to DC and then converting it straight back to AC again, we're able to join two networks together which are perhaps fed from different primary substations or different groups of network. The sharing is controlled because we've got monitoring at the two substations, and with the monitoring we're able to, we have an algorithm within the soft open point that decides, right, now's the time to transfer 50 kilowatts from substation A to substation B. And as the day progresses, the demand profiles change, and then substation B is the one that is more lightly loaded because substation A is now looking after residential customers. They've all come home, the demand increases. So the device says, right now substation A is more heavily loaded, and we transfer power from B back to A.
And so the problem you're trying to solve, as far as I understand it, is that, and the funding came from the regulator. The regulator as well. Is what are you preparing the low voltage grid for by doing all of this? Is this preparing it for? Everybody here is talking about demand response. That world. Lots of other people are talking about the day we're all going to run to IKEA and buy solar panels and slap them on without telling you.
So the Flexible Urban Networks at Low Voltage project is all about trying to ensure that we are able to make use of the capacity that exists in our network already. So in a busy city centre, you could have one substation at certain times of the day that could be 80% or more loaded within to its rating, and we then want to be in a position where we say, well, there's a neighbouring substation which is lightly loaded, so instead of having to upgrade the heavily loaded substation,
make this one bigger and bigger.
And there comes a time when you can't get a bigger transformer into that space because the substation is a finite area. We're now saying, well, we've got the spare capacity at a neighbouring substation, we will support that network, and we're looking at perhaps transformer utilization, equalization. So if you've got two transformers and they're both, say, 800 kVA rated, if you've got one which is only at 50% rating and loading, and the other more heavily loaded, you'll be able to shift and equalize, so you're reducing the burden on the heavily loaded substation.
So it seems like you've got a much more flexible and agile grid at your hands. I'm doing this because I'm switching between two substations.
Exactly. And that is it. It is very much a autonomous system. So now I'm talking with my hands. The demands vary as the day progresses, and the power transfer is optimized through an algorithm which was developed by Imperial College in London, and that is providing us with the ability to make use of other functions that power electronics deliver. So Turbo Power Systems, the company based in Newcastle who's developed these soft open points, have not just restricted it to real power transfer. We can do reactive power transfer. We can manage the voltages. So when you've got a generator connected, when the generator is producing output, it naturally causes the voltage to rise. The power electronics device, the soft open point, will be able to keep the voltages within a certain tolerance, providing additional headroom, allowing that generator to continue to export whatever energy it's producing. So in the form of photovoltaics, if you've got voltages approaching towards the upper limit, that inverter belonging to the power electronics, the photovoltaic, will stop exporting because it hasn't got that differential.
Right.
The power electronics device, our soft open point, will maintain a voltage differential and allow that generator to maximise that renewable energy. We're also looking at the imbalance between our phases and trying to improve the power factor. All these things, if you can reduce the amount of current flowing through the neutral conductor, you are reducing losses. So these are all various things. But I think there's been talk about soft open points for a long time, and this is really the first time we've had the opportunity to write a functional specification, go out to tender to two companies saying, this is the type of device that we want. Can you make something that meets this functional specification? And we've now not only during the project done that design, done the testing, made sure that we're comfortable with it connected on our network, that we're now at the stage where we're monitoring its impact, and the challenge now over the next 12 months is to realise that business case. Show that it's not just a simple switch. It is more than a switch. It can do all these other functions that we haven't had.
I was going to come on to that because you're clearly you're excited by it, and just with you explaining it, it seems like something that was. I'm trying to find the right word. Something that was not as dynamic, or needed to be, but wasn't because the tech wasn't there, is now a very dynamic thing. And if you were to blue sky for a second, what does this now enable you to do? Because whenever you do this stuff, you do it to solve one problem, and you suddenly go, hang on a minute, that's going to solve this one and that one and that one.
Yeah. Well, this is it. So initially the project had been focused on the low voltage. With low voltage, you're dealing with DC voltages which are still less than 1,000 volts. So we're all within our safety rules. We know what we're doing with regard to the AC side of things. Yes, we've had a lot of learning as to, well, what does DC at this voltage really mean? What precautions? How do we ensure that our staff are properly trained? We've still got to manage that network, which this device is now embedded within. But the challenge is, instead of just focusing on urban city centres where the cost of trying to establish a new substation can be prohibitive, and it can take several years to get that little space where the substation is required, can take a long time. So looking at, can we...
Especially in places like London, right?
Especially in London,
yeah.
Where you're looking at occupying a space which is typically going to be in a basement, but that basement is also used for car parking.
Yeah.
And what's the value of a car parking space compared to a substation? And it's quite challenging.
Yeah.
So we're looking at, well, where else on our low voltage networks could this soft open point provide us with benefits? But it doesn't stop there. Once we've learned that we can demonstrate real power transfer, equalization between substations, reactive power transfer and voltage support, it doesn't have to remain at that low voltage network. You can start thinking, well, how would we start thinking about a higher voltage, a medium voltage, or 11 kV? These are going to be much bigger devices. I haven't really described how big our device is. It's the 2-terminal device is a bit like a large cupboard.
Right.
It sits on the pavement, and where we got these devices operational, people are just walking past, ignoring them. It's not as yes, it's a new piece of street furniture, yeah. But it's not drawing any
innocuous, right?
It's already got the graffiti on it.
But excellent. So that means it's been adopted. It's been adopted and assimilated. So on that note, we're going to have to leave it. I enjoyed talking to you, and I hope you enjoyed watching this interview. There are many more on Engerati.com, and I'm going to have a word with Peter off air and see whether we can't get some of the collateral they may have and wrap it around this interview, because that'd be a useful exercise, I think, as well. But thank you again for watching, and thanks for joining me.
Thank you very much.
Thank you.